In these next two problems, we are given a slope and a point. So looking back at our chart here, it says that if you're given the slope and a point, you should start with the point-slope form, this temporary form that we have as your starting place, and then move from that to either standard or y-intercept, depending on what the direction said. So for the first one, the y minus y1 equals m times x minus x1. That is our point-slope form, and we're going to start there with this information and then rearrange it into slope-intercept form. So this problem has a y minus our y1, which is 5, and it equals m, the 3/5, times x, which is, or x minus our x1, which is 2. So I distribute the 3/5 through. Y minus 5 equals 3/5 x minus 6/5. And I'm almost in slope-intercept form. I've got the y and the x in the right place. I just need to get this minus 5 to move over here and join the rest of the b. So by adding 5 to both sides of the equation, when I add my 5 over here, though, I'm going to write it as 25/5. 25/5 is the same thing as 5, but it gives me that common denominator that I need in order to be able to do the addition. So that'll leave me with a final form of y equals 3/5 x minus 6 plus 25 would leave me with a plus 19/5. For problem 35, I'm again given the slope and a point, so I'll start with this form, but my end goal is to have my equation in standard form. So y minus 5 equals negative 3 times x minus 2 gets my x1 and y1 put into the correct places, and my m put into the correct spot. I use the distributive property to carry that negative 3 through. And now this time I'm headed towards standard form. So I want to move this negative 3x over to the other side of my equation. And I want to move the negative 5 to the right side of the equation. So this will get rid of those. This will get rid of those, leaving me with 3x plus y equals 11. In these next two problems, we're given 2 points. So if we come back here and look at our chart again, the chart says if you're given 2 points, use those 2 points to find the m, and then pick one of the points to use in the point-slope form. So first I'm going to find my slope, and that is my change in y, so 7 minus 1, over my change in x, negative 5 minus 2. 7 minus 1 is 6, a negative 5 minus 2 is going to leave me a total of negative 7. So that is my slope. Then choosing the point to use for the point-slope form can be either one of these 2 points. Since this one doesn't have any negative numbers in it and it has a 1 in it, it feels like it's probably the easier point to use. So I'm going to pick that point as the point to use in my point-slope form. So putting that in, I get y minus 1 equals a negative 6/7 times x minus 2. Distributing the 6/7 through, there's a negative 6/7 x plus 12/7, since 2 times 6 is a positive 12. Then I'm headed for slope-intercept form, which means it's just this minus 1 that I need to move by adding 1, and on the other side, since I have to combine it with sevenths, I'm going to add my 1 written as a 7/7. So now I have y equals negative 6/7 x plus 19/7. I'll start this next problem the same way, by finding my slope. So it's the difference in my y's, 3 minus 7, over the difference in my x's, 2 minus 4. Well, 3 minus 7 is a negative 4, and 2 minus 4 is a negative 2, and that reduces to a positive slope of 2. Picking one of my points to be my x1, y1. In this case, it doesn't look like really either point's easier, so I'm just going to use the first one. I get y minus 3 equals 2 times x minus 2 when I put it into the point slope form. I'll distribute the 2 through. Y minus 3 equals 2x minus 4. And then it says that my goal here is eventually to get this problem into standard form. So I'll need to, just like I have in these other ones in standard form, when I needed to move the 5 and the 3x to the opposite sides, in this problem I'm going to need to move the 2x and the negative 3 to the opposite side. So I'll take 2x's away from both and add 3 to both. That gets rid of the 3's on that side and the x's on that side, and leaves me with a negative 2x plus y on the left, equaling negative 4 plus 3 will be a negative 1. Then one more step, because I need this coefficient on the x to be positive. So I'm going to multiply the whole equation by negative 1 in order to get that 2 to be positive. So my final answer to this problem is 2x minus y equals 1.